right. Uh, Letter C. No, a paragraph proof. But we could do this. Give a paragraph proof of theorem 58.3. And actually, this one, as far as paragraph proofs go, this one's not too bad. So watch this. I'm going to connect this line as well. This is not a given, but I'm going to connect it. I'm going to connect this, and I'm going to connect this. That's the hint. It tells you to make sure you draw these things. Okay, so what I am going to state, let's see, we're going to write our paragraph proof over here. Let's just go inside this one and pull this out to the edge of the page because we're going to need lots of room for this. All right, give a paragraph proof of theorem 58.3 that says that I have to prove that AB is congruent to AC. Okay, so it says that in my proof statement here, if I can prove that those two are congruent, well, now that I've drawn these two little triangles here, if I can prove that these triangles are congruent, then I can prove that AB is congruent to AC. Okay, so that gives me somewhere to start. I'm always going to start with my givens as well for the most part. So it is given that AB and AC are tangent to circle P, right? And wait a second. If they're tangent, that means that they form right angles with the point of tangency. So that's helpful. That's theorem 58.1. If a line is tangent to a circle, it's perpendicular to the radius drawn to the point of tangency. So I can say by theorem 58.1, um, angle PBA and PCA are right angles. They're perpendicular, so I should actually go one step further and say they're perpendiculars, and perpendicular lines form right angles by the definition of a perpendicular line. Um, but I'm not gonna. I'm just gonna assume that you know that right angles are 90 degrees and 90 degrees right angles. So anyway, they're right angles and triangles PBA, well, triangles. Let's try that again. PBA and PCA are right triangles by the definition of right triangles, which says that they have to have at least one right, or they have to have exactly one right angle. Um, okay. Hey, if I'm dealing with right triangles, that opens up a bunch of theorems to me um, that prove for me to prove, remember, because I need to know like two sides or one angle and one side, maybe the hypotenuse and an angle. In this case, what can I prove? Well, I know that, first of all, I'm just going to do the easy one. PA is congruent to PA by the reflexive property of congruence. Hey, I already have the hypotenuse of my two right triangles is congruent. I just need one other side. Also, PB and PC are radii of the of circle P by the definition of radius. Okay, and we know also by the definition of radius that the radius is always the same value. It's from the center of the circle to the outside edge of a circle. The definition of a circle is all points that are the same distance from the center of the circle. So I'm going to say, and PB is congruent to PC by it's actually the definition of a circle, because we know that PB is the same distance. It has to be the same difference as PC because they're both in the circle and they're both radii. Okay, so now I know that I've proven, I have it in record that PA is congruent to PA and PB is congruent to PC. That means that I can say triangles PBA and PCA are congruent and let me just think, I know the hypotenuse and one of the legs. So this is by the HL right triangle congruence theorem. Those ones are all theorems. Okay. And AB is congruent to AC by corresponding parts of congruent triangles are congruent. Done. I've proven it. Okay. That was not a bad paragraph proof. Did you follow the reasoning there from beginning to end?